Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 11, Lesson 2, Solving Systems by Substitution. Now, in our last lesson we reviewed what a system of equations was, all right? But we didn't have any methods for solving systems except for the graphical method that we saw, like 6 units ago or something like that when we had our unit just on equations of lines. Today, we're going to see probably the most important method for solving a system of equations, and that's known as solving systems by substitution. So let's get right into it right away. Now, we've seen how to solve a system graphically by finding the intersection points of two lines, but we will also solve systems algebraically. The most common way, as I mentioned already, is by substitution, which relies on a very important idea, one that you actually use all the time already in math, which is the substitution property of equality. And what this really important property of equality says is that equals may be substituted for equals in any equation and it will remain a true equation. All right? And again, it kind of makes sense. If two things are equal, you can replace one with the other and it doesn't change whether or not the thing was true in the first place. So let's kind of see how that plays out in exercise number 1. Given the system x plus y equals 14 and y equals 3x minus 2, do the following. Letter A. Show that x equals 4 and y equals 10 is a solution to this system. All right, great. So why don't you go ahead and do that? We reviewed how to check to see if a particular set of values was a solution to a system. Pause the video and just make sure that you review that very important idea. All right, well, real easy to see that these two values solve the first equation, but let's, we got to make sure we do it. Let me just write my first equation down, y plus x equals 14. If I put 4 in for x and I put 10 in for y, then yeah, 4 plus 10 is 14, 14 equals 14, awesome. Now let's go with the other equation, y equals 3x minus 2. So if I put in, 10 for y, 4 for x, then I'll see that 10 is equal to 12 minus 2, and 10 is equal to 10. You bet. All right, so that's a solution. And again, remember, it's a solution specifically because this set of values makes this equation true and this equation true at the same time. But what this doesn't help you with is how to actually find x equals 4 and y equals 10 if you're given this system to begin with. So let's see how we can use substitution to find that solution. Letter B. Solve the system by substituting y equals 3x minus 2 into the equation x plus y equals 14 for the variable y. All right, so remember, the principle of substitution says that when things are equal, y equals 3x minus 2, then I can replace y with the expression 3x minus 2 and it will continue to be true. So literally what substitution says is, let me take my two equations and just rewrite them so you see them nice and big. All right, is that I can take this 3x minus 2 and I can substitute it in for that y. So when I do that, I get x plus 3x minus 2 is equal to 14. Now, before we go on with this problem at all, let me point out something that's really kind of critical now. This equation, which is really kind of a combination of this one and this one, if you think about it, has only one variable in it. And because it's got only one variable in it, I can solve that equation for the value of that variable. And let's go ahead and do that. Right? We now have x plus 3x is 4x, so just, combining some like terms there. Now, of course, I've got a classic two-step equation, so I'm just going to add 2 to both sides and get 4x is equal to 16. All right, let me bring that kind of up here. 4x equals 16. I can now solve that by dividing both sides by 4. And I get x equals 4. Now, let's step back again for a second, right? Taking a look at letter A, where it said show that x equals 4, y equals 10 is a solution, there's our x equals 4, right? And we were able to get x equals 4 by substituting 3x minus 2 in for this y into this equation, and we could do that because y equals 3x minus 2. Y equals 3x minus 2. So we now have the x value that solves our system. How do we find the y value? Well, that's really easy. I can take this x value and I can substitute it either into this equation or into this equation, either one of them, to figure out the value of y. Now, which one do I want to substitute it into? Well, it shouldn't make any difference. And by the way, if it does, then this is the wrong x value. All right, so whichever one seems easier to you, awesome. This one might seem easier to you, right? Because if I put x into this equation, if I take my x equals 4 and put it in here, I'll have 4 plus y equals 14. And if I subtract 4 from both sides, I'll get y equals 10. And there they are, right? X equals 4, y equals 10 is our solution to the system. The main method for solving systems of equation is substitution, because it allows us to take two equations that have two variables, x and y, and change them into one equation with only a single variable. We can then solve for that variable, take its value, substitute it into either one of the original equations, and solve for the other value. That's it. That's the method of substitution. So let's get a little bit more practice with it, because boy is it handy. Now, the algebraic method of substitution works very, very well if one or both of the equations has a variable isolated, i.e. it's like all by itself on one side of the equation. So let's look at another situation like that in exercise number 2. Solve the system shown below by substitution. Carefully show each step. Check your final solutions. All right, great. Now when we look at these two equations, and let me write them just a little bit bigger, y plus 3x equals negative 1 and x equals y minus 7. All right, when we look at these two equations, notice, right, in this equation both the y and the x are on the same side of the equation. But in this one, the x is isolated. It's all by itself. So I can actually substitute y minus 7 in for this x right here. Now I have to be a little careful though. This x is being multiplied by 3. So that means this entire y minus 7 has to get multiplied by that 3. So let's do the substitution together on this and then see if you can finish off the problem. So I'm going to take my y minus 7, which is what x is equal to, and I'm going to substitute it into that equation. Now what that's going to leave me with is y plus 3, and get these parentheses in there, 3 times y minus 7. All right, it is exceptionally important that you have the parentheses in there, because if you don't, and let me just erase them for a minute and then I'll put them back in. If you were to write something like this down, then obviously the only thing that's getting multiplied by the 3 is the y. And yet x is equal to y minus 7. It's not equal to y, and then there's a minus 7 sitting here. Every part of that x has to be multiplied by the 3, and the negative 7 is part of that. All right, now what I'd like you to do is pause the video and see if you can finish solving this system of equations. First solve for the value of y, and then substitute that value into either one of these equations to find the value of x. Pause the video now. All right, well, let's do it. I'm going to take this one up here. First thing I'm going to do is I'm going to use the distributive property to distribute that 3 through the parentheses. So that's going to give me y plus 3y minus 21 is equal to negative 1. I'm going to combine the y and the 3. I'm going to try to combine the y and the 3y into 4y minus 21 is equal to negative 1. I'm going to add 21 to both sides. Negative 1 plus 21 is positive 20. I'm going to divide both sides by 4, and I'm going to get my y value is equal to 5. All right, awesome. I have my y. And again, as soon as we've done substitution, as soon as we've done that substitution, then after that, we should just be back to like some grade A algebra that you've been learning in like entire middle school, 6, 7, and 8. Maybe not in Math 6 you wouldn't have been solving this, but certainly by last year, you would have been able to solve this equation by using the distributive property, combining like terms, and then just doing a two-step equation. Now let's get our value of x. And never forget, you got to get both values, both x and y, a and b, m and n, whatever the variables are called. Now, which one of these two equations do I want to substitute y equals 5 into? Well, the easier one is going to be this equation because it literally says x equals y minus 7. So I can now just say, well, x equals y minus 7. So let me just bring this up a little bit and extend my page. Since y is 5, I can just put that in there. Be careful, 5 minus 7 is negative 2. And those are the values that solve. Now this problem also asked us to check our solutions, all right? And that is not a bad idea, right? And how do we check our solutions? Well, we check them exactly doing what we did in exercise number 1, exactly what we did in the last lesson. I want to take these two values and see if they make these two equations true, all right? So let me just carve out a little bit of room right here to do my check. All right, carve out a little space. So let's first check to make sure they make this equation true. So I'm going to put 5 in for y. I'm going to put in negative 2 for x. All right, 3 times negative 2 is negative 6. And 5 plus negative 6 is negative 1. So that works. My other equation was x equals y minus 7. All right, in this case, I'm going to put negative 2 in for x. I'm going to put 5 in for 5 in for y. 5 minus 7 is negative 2. Negative 2 equals negative 2. All right. It is never a bad idea at the end of solving a system, right, when you've gotten the values of your two variables, to plug them back into each one of the equations to make sure that they're each true. If either one of these are not true, then either that's not a solution to your system, or possibly something went wrong with your check. And that can happen, right? I mean, when you make a mistake in math, it could happen over here, or it could happen in the thing that you're supposed to be using to make sure you didn't make a mistake over here. And that can be a little tricky. All right, now, substitution so far has been fairly easy. There is a situation, though, that you need to be really, really careful for. So let's check that one next. All right, substitution can be tricky if subtraction is involved. Always make sure to use the distributive property correctly. So let's take a look at that in exercise number 3. Solve the system below by substitution. Then check your answer by substituting back into both original equations. All right, great. So again, let me write these a bit bigger. 5x minus y is equal to 19, and y equals 2x minus 1. Okay, so again, what's really nice about using substitution here is that our y is isolated. So we can easily take our 2x minus 1 and substitute it into this equation for y. But we have to be careful, all right? Because y equals 2x minus 1. It's equal to all of this, and all of this needs to get subtracted. The most common mistake in a problem like this is that a student would take this, they know exactly what they're supposed to do, they would substitute it in here, and they would do something like this. All right, so let's step back and talk about why that's incorrect, okay? It looks correct. It looks like, hey, I just took the y and I put a 2x minus 1 where the y was. The problem is this is not 5x minus y. This is 5x minus 2x, and then we're subtracting 1. But I should be subtracting this entire binomial. All of that should get subtracted away. Now, the result of that means, I'll end up having a negative 2x, but subtracting a negative 1 should turn it into a plus 1, okay? So what I'd like you to do is take it from here and try to finish solving this system and also try to do the check. Pause the video now, and then we'll go through all of it once you're done. All right, and again, you can really think about this as almost multiplying through this parentheses by the number negative 1. It's not a bad way to look at it. Then I have negative 2x plus 1 equals 19. Of course, 5x minus 2x is equal to 3x, plus 1 is equal to 19. Now I have a two-step equation. Subtract 1 from both sides. I'll have 3x is equal to 18. Divide both sides by 3, and I'll get x is equal to 6. All right? So there's my x value, the x part of my solution. I've got to get both variable values. So I can take this and substitute it into here or here. This is going to be the far easier one to figure out what y is because it literally says, hey, y equals blank, right? So I'm going to take that thing and I'm going to substitute in my 6, and y is going to be 11. By the way, when we do that substitution, right, when we take that 6 and we plug it in here to get y, you know what we're using? The substitution property of equality. We're just using that same property again. We use it often without almost thinking about it. Now let's do the check. I think I can squeeze the check up in here. So let's take a look at our check. Now we want to check that set of values in both equations. Let me start with the first one, 5x minus y is equal to 19. So I'll put 6 in for x, 11 in for y. All right, 5 times 6 is 30, right? And 30 minus 11 is in fact 19. So you bet it works in the first equation. Now let me put it into the second equation, y equals 2x minus 1. So if I put 11 in for y, and I put 6 in for x, I'll get 2 times 6 is 12, and 11 equals 11. All right, a good check, a good check. Now, by the way, if you're the kind of person, and trust me, I fall into this category a lot, where I'm like, man, I'm pretty confident those are right, I'm not going to check. All right, look, if you're going to take the easy way out, right, now on this problem it says check your solutions, but let's say it didn't, right? If you want to make sure your solution is correct, right? Now, remember here, when I did x equals 6, I plugged it into this equation and got y equals 11, okay? That pretty much means by default, these two values are going to make that equation true. I should at least check them in this one. The equation I don't use to find the second variable value, all right, that's the one I should definitely check them in. That's the one that could possibly tell me that I made a mistake over here. All right, let's keep going with some systems. Now, there's a special case that comes up a lot when you solve a system by substitution, and that occurs when both equations have the same variable isolated, oftentimes the variable y. Okay? We often refer to this as setting the equations equal to each other. And I like to actually introduce these phrases like setting the equations equal to each other, even though we're just going to use the substitution property of equality. You'll oftentimes hear teachers say, all right, folks, let's solve this system by setting the equations equal to each other, or let's find the intersection points by setting the equation equal to each other. So let's take a look at how this works in exercise number 4. Find the intersection point of the lines whose equations are shown below algebraically. Now remember, right, the idea is the solution to a system of equations will be an intersection point of those two equations. Notice in this case, both of the y variables are isolated. And that means I could either take 4x minus 23 and substitute it in for this y, or I could take negative 2x plus 1 and substitute it in for that y. Either way, when I do that substitution, and let me take this one and substitute it in for that y, it appears like I am setting the equations equal to each other. Do you know what I mean? Because I'm taking 4x minus 23 and I'm setting it equal to negative 2x plus 1. That's not really what I'm doing. What I'm really doing is taking 4x minus 23 and replacing y with it by using the substitution property of equality. But what it looks like visually is setting the equations equal to each other. Well, now that we've done that, why don't you go ahead and finish solving this system? All right, let's do it. So now we've got an equation where we've got variables on both sides. So I think the first thing I'm going to do is I'm going to move all my x's over to the left-hand side by adding a 2x to both sides. Those will cancel. I'll now have 6x minus 23 is equal to 1. add a 23 to both sides to get rid of the 23 from the left-hand side. That'll give me 6x is equal to 24. Now I'll divide both sides by 6. Boy, I like x equals 4 as a solution. And I get x equals 4. All right, so that's the x-coordinate where these two lines intersect. What is the y-coordinate? Well, now I can take that x equals 4 and I can substitute it into either one of those equations. I think I'll just put it into the first one. Why not? So the y is equal to 4 times 4 minus 23. So that's going to be 4 times 4 is 16 minus 23. Here we have to be a little careful, but of course you could always use your calculator on this, and I'll get y equals -7. All right. Now, remember, this problem didn't tell us to check, okay? It didn't say to check, we don't have to check, whatever. But let's say I want to be good about knowing whether or not my work is correct or not, right? I want to do that. So, what can I do? Well, remember, to produce this y value, I took that x and I plugged it into this first equation. I didn't use this one at all to come up with this y value. So if you're going to do like a half check, as I would put it, I would now take the 4, plug it into this equation, and make sure you still get -7. Or plug both of them into this equation and just make sure it's true. So maybe I'll do that over here. Watch, I'm gonna do a little check, a half check over here. All right, and I'm gonna do that by putting -7 in for y and 4 in for x. That's gonna give me -7 equals -8 plus 1. And in fact, -8 plus 1 is -7, and that works. Now, I wouldn't want to do a half check by taking these two and putting it into the first equation, because literally that's the equation I used to produce the y value after I knew the x value. That one's definitely going to check, okay, unless I somehow botched the arithmetic right here. But by plugging these two values into the second one and seeing that it works, we can rest assured that this is a solution to the system. All right, let's take a look at one last problem. Okay? Now, some real-world scenarios are really well modeled with systems that can then be solved by substitution. And we're going to see a ton of these in lesson number 4 in this unit. But let's take a look at one right away. Exercise number 5. Michelle and Nina finish a day at the amusement park with ride tickets left over. Michelle has 4 tickets more than Nina. Together, they have 20 tickets. Let M be the number of tickets that Michelle has remaining, and N be the number of tickets that Nina has remaining. Letter A, model this scenario with a system of equations. All right, well, let's do this together, okay? So, you've done lots of word problems before using the algebra that you've learned in Math 6, 7, and 8, but you've never had to set up a system before. All right, so we've got these two variables. M is however many tickets Michelle has, N is however many tickets Nina has. Now, one thing I know for certain is that together they have 20 tickets, which means if I take the number of tickets that Michelle has, and I add the number of tickets that Nina has, I have to get 20. Because again, together, they have 20 tickets. So that is one of the two equations that's involved in my system. But where do I get the other one? Well, the other one comes from this statement. Michelle has 4 tickets more than Nina. That means that Michelle's number of tickets is Nina's number of tickets plus 4 more, right? Michelle has 4 tickets more than Nina, right? And if I told you Nina had 15 tickets and Michelle has 4 more, you'd say, well, Michelle has 15 plus 4. Oh, Michelle has 19 tickets, right? Right? No matter what, however many tickets Nina has, if I take her tickets and I add 4 to it, I'd have to get the number that Michelle has, because Michelle has 4 more tickets than Nina. And this is a wonderful system of equations that can be solved with substitution, and that's what I'd like you to do in letter B. Go ahead and figure out how many tickets each one of them has by solving this system. Now, this system is nicely solved by substitution because our second equation, the m is isolated. So what I'm going to do is I'm going to take my n plus 4 and I'm going to substitute it in for that m, and I'm going to get n plus 4 plus n is equal to 20. Obviously, I can collect those two n's together and literally get 2n plus 4 is equal to 20. Subtract 4 from both sides. I'll get 2n is equal to 16. Divide both sides by 2 and give myself a little bit of room. and I'll get the number of tickets Nina has is 8. Right? Simple enough. Nina has 8 tickets. And now I can use this equation, or this one, it really doesn't matter, but let me use this equation to figure out that Michelle has 8 plus 4, or 12 tickets, right? Now remember, I used that second equation to come up with how many tickets Michelle had. I could now use that first equation to kind of check, right? Michelle's tickets plus Nina's tickets, 12 plus 8, in fact, gives me the 20 tickets that they have together. So a situation that's well modeled and easily modeled using a system, and then that system is easily solved using substitution. All right, let's wrap this up. So we have now seen 2 methods for how we can solve systems of equations. One of them is graphically, by graphing both lines and finding their intersection point. And one of them is by substitution, and that is particularly helpful if one of the 2 equations has a variable isolated, because we can then take the expression that that variable is equal to, substitute it into the other equation, giving us really a combination of the 2 equations with only one variable. We then solve for that variable, take its value and substitute it into either of the 2 original equations to find the value of the other variable. Substitution is by far and away the most important method for solving systems of equations. We will see an additional method, the method of elimination, in lesson number 3, and it's a great method and it's kind of cool and a little gimmicky, all right, but it's not used really nearly as much as substitution when systems arise later in math and science. All right, we're going to see that method in the next lesson. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.